Hey there, algebra students. Mr. Lawrence here, and another mixture problem. I'm going to do another mixture problem video because we've spent so much time on mixtures. Got to make sure you know it. They're on the review sheet. Got to make sure you know how to do them. Okay, let's get down to this. Oh no, I lost my connection. I turned my airliner off. Silly, Mr. Lawrence. All right, this one's going to have two problems on it. Shelly has 37 coins. Some are dimes and some are pennies. She has a total of $1.99. How many dimes and pennies does she have? First I'm going to do is define my variables. I'm going to let D equal, not dimes, the number of dimes. Okay? And then I'm going to let P equal the number of pennies. Okay? And I think I did this with a chart in the last video, so I'm going to do it without a chart this time. First thing I'm going to do is I'm going to write an equation. You know what? Maybe you guys want a chart better. So let's go coins. Right? And so we're going to have pennies, we're going to have dimes, and then we're going to have the number, okay, coins are going to be, type of coins, penny, okay, and then we're going to have a dime. And how many pennies and dimes do I have? Well, I don't know. I have P pennies, and I have D dimes, okay. I'm going to need the value. And the value of a penny is 0.01. The value of a dime is 0.1, right? And then down here, I'm going to have some totals, and the total number of coins is going to be 37, okay? And the money from the coins is going to be 0.01p. That's the money from the pennies. I'm going to have 0.10d. That's the money from the dimes. And altogether, that's going to equal $1.99. Okay, and I don't put anything in this box. And then I just have two equations. I have an equation here, and I also have an equation there. I think in the past I've set these up horizontally, but this is making sense to me, so I'm doing it this way. Hopefully it won't screw you up. Shouldn't be a big deal. My first equation is going to be p plus d, and that's going to equal 37. And my second equation is going to be 0.01p plus 0.10d, and that's going to equal $1.99. Looks like a good problem to do by substitution. I think I'm going to solve for d, and so d is going to equal 37 minus p. So I'm going to substitute this in for d. 0.01p plus 0.10 times the quantity of 37 minus p equals $1.99. All right, so 0.01p plus 3 7/10 minus 0.10p, and that's going to equal $1.99. I'm going to combine my like terms on the left-hand side, and it looks like 10 pennies and 1 penny. I have 1 penny. I owe 10 pennies. I'm going to be at 0.09p plus 3.7, excuse me, 3.7. That's going to equal $1.99. Okay, so, by the way, if you know what I did, I combined the p terms, right? Okay, now I've got to get rid of this 3.7, right? But some of you will have a hard time subtracting here. Don't subtract that. Do $3.70 minus $1.99. And then borrow, right? We don't have enough, so we're going to go 2, and then we're going to go, we're going to borrow here, we're going to get 10, and we're going to get 16, right? So that's going to be 1, that's going to be 7. Oh, that's bothering me. Did I make a silly mistake there? That's not seeming right. Let me check it. $1.77 plus $1.99. Is going to be 0, carry the 1, it's going to be 7, and carry the 1, 3. Nope, we're good. Okay, felt like I made a mistake. Probably been working too much lately. That's okay, you guys are worth it. All right, P is going to equal, my answer was $1.71, right? So now I'm just going to divide by, oh, it's a negative answer though. Divide by negative 0.09p, just by 0.09, sorry, negative 0.09. And so the number of pennies is going to equal, let me grab my calculator, 1.71 divided by 0.09 And I get 19 pennies. That's good. If I don't get a whole number, I know I screwed up. Now, I know 37 minus 19, the number of pennies, total number of coins, is going to be 18. So therefore, there are 18 dimes and 19 pennies. All right, one problem that we talked an awful lot about, if you remember we did some demonstrations, people got to push me from behind and from the front, was current problems. So we have an airplane traveling with the wind, and it goes 1,000 miles in 5 hours. Well, I need P plus the wind. Now, remember, P is the speed of the plane, right? W is the speed of the wind. I need a speed over here. I can't put 1,000 miles. I can't put 5 hours. Remember, distance equals speed times time. If I solve that equation for S, to get S alone, I get the equation that S, or speed, equals distance divided by time. So I'm going to take the distance, 1,000 miles, and I'm going to put it over 5. There's my first equation. Now the return trip is P minus the wind, because the wind is slowing down the plane. I'm still going to have 1,000, but I'm not going to have 5 in the denominator. I'll have a 6.5. So this system I'm going to solve is going to be P plus W equals 200, and P minus W, which is going to equal, I don't know, 1,000 divided by 6.5 off the top of my head. It's going to equal 153.85, and I'm going to round it to the nearest hundredth. Okay, now this is screaming at me, hey, do me by elimination. So I am. I'm going to do 2p, and that's going to equal 353.85. Okay, I'm going to divide by 2. I'm going to divide by 2, and so p is going to equal 353.85. 353.85 divided by 2 is going to be 176 and approximately 93 miles per hour. It's going to be the miles per hour of the plane. Now to get the speed of the wind, I'm going to plug in 176 and 93 hundredths in for P, plus W is going to equal 200, and then I'm going to solve the one-step equation. So I'm going to subtract 176 and 93 hundredths, 176 and 93 hundredths. Okay? And so I'm going to think, well, if this was just a plain old 76, my answer would be 24, right? But I'm taking more than 76 away, so it's going to be 23, and then I'm going to make this a whole, 17. There you go. So the speed of the wind is going to be 23 and 17 hundredths miles per hour. All right, there you go. Mr. Lawrence signing off. Yay, I think this is going to be my last video unless somebody sends an email saying I'm not sure what to do. All right, here we go.